Caesar cipher. Caesar cipher is one of the simplest and widely known encryption techniques. It is a type of substitution cipher in which each letter in the plaintext is replaced by a letter shifted a certain number of places down the alphabet. The technique was named after Julius Caesar, who used it to communicate with his officials. In Caesar's time, the letter shift was set to 3, but it can be set to any number of positions as desired. The encryption process involves replacing each letter in the plaintext with the letter that is located a certain number of places down the alphabet. The Caesar cipher is an example of a symmetric key encryption, meaning the same key is used for both encryption and decryption. The key in this case is the number of positions that each letter is shifted. The encryption process is simple and easy to implement, making it a popular choice for introductory cryptography courses. However, the Caesar cipher has several weaknesses, including the fact that it only uses a single letter shift and can be easily broken by a simple frequency analysis. The Caesar cipher can also be easily solved by a brute force attack, where every possible key is tried until the plaintext is revealed. In conclusion, the Caesar cipher is a simple and historically significant encryption technique, but it is not suitable for modern cryptography because of its many weaknesses. Its significance lies in its place as one of the earliest known examples of encryption, and its role in the development of more advanced encryption methods. How Caesar cipher works. Caesar cipher works by shifting each letter in the plaintext by a fixed number of positions down the alphabet to form the ciphertext. This number of positions is referred to as the shift, or key, and is usually set to 3 for the Caesar cipher. For example, if the key is 3, the letter A would be encrypted as D, B would be encrypted as E, and so on. To decrypt the ciphertext, the reverse process is performed, where each letter is shifted back by the same number of positions to recover the plaintext. The Caesar cipher is a type of substitution cipher, meaning that it replaces each letter in the plaintext with another letter or symbol. In this case, the replacement is performed by shifting the letter a fixed number of positions down the alphabet. While the Caesar cipher is simple to implement, it is not secure by modern cryptography standards due to its limited key space and susceptibility to frequency analysis attacks. It is mainly used as a learning tool to introduce the concept of cryptography and encryption. Caesar cipher mode 26. Caesar cipher with a shift value of 26, or a multiple of 26, is sometimes referred to as a null cipher or identity cipher, because the ciphertext is exactly the same as the plaintext. This is because shifting each letter by 26 positions simply cycles the alphabet back to the original letter, and no encryption or decryption is performed. For example, if the key is 26, the letter A would be encrypted as A, B would be encrypted as B, and so on. Similarly, if the key is 52, which is a multiple of 26, the encryption would again be the same as the original plaintext. In general, a Caesar cipher with a shift value of 26, or a multiple of 26, does not provide any security, and should not be used for encryption purposes. Caesar cipher encryption and decryption formulas. The Caesar cipher encryption formula is given by CI equals P I plus key %26, where CI is the ITH letter of the ciphertext, PI is the ITH letter of the plaintext, are represented as an integer between 0 and 25, where A equals 0, B equals 1, Z equals 25, and key is the shift value, also represented as an integer. The Caesar cipher decryption formula is given by P I equals C I key plus 26, %26, where P I is the ITH letter of the plaintext, Ci is the ith letter of the ciphertext, but represented as an integer between 0 and 25, and key is the shift value. These formulas assume that the alphabet consists of 26 letters, and the letters are represented as integers between 0 and 25. The modulo operation, %, with the value 26, is used to ensure that the result of the encryption or decryption operation remains within the range of 0 to 25. Caesar cipher example. Here is an example of the Caesar cipher encryption and decryption. Process. Plaintext, hello world. Key, 3. Encryption. Convert each letter in the plaintext to its corresponding number, where A equals 0, B equals 1, Z equals 25, H equals 7, E equals 4, L equals 11, L equals 11, O equals 14, W equals 22, O equals 14, R equals 17, L equals 11, D equals 3. Shift each number by the key value, 3, modulo 26. 7 is equal to 10, A, 4 is equal to 7, H, 11 is equal to 2, B, 11 is equal to 2, B, 14 is equal to 17, Q, 22 is equal to 1, A, 14 is equal to 17, Q, 17 is equal to 20, U, 11 is equal to 2, B, 3 is equal to 6, F. Convert each number back to its corresponding letter. 10 equals K7 equals H2 equals B2 equals B17 equals Q1 equals A17 equals Q20 equals U2 equals B6 equals F. The ciphertext is KHBQB. Decryption. Convert each letter in the ciphertext to its corresponding number, where A equals 0, B equals 1, Z equals 25, K equals 10, H equals 7, B equals 2, Q equals 17, A equals 0, Q equals 17, U equals 20, B equals 2, F equals 6. Shift each number by the negative of the key value, -3, modulo 26. 10 is equal to 7, H. 7 is equal to 4, E. 2 is equal to 11, L. 17 is equal to 14, O. 0 is equal to 25, Z. 17 is equal to 14, O. 20 is equal to 17, R. 2 is equal to 11, L. 6 is equal to 3, D. Convert each number back to its corresponding letter. 7 equals H4 equals E11 equals L14 equals O25 equals Z14 equals O17 equals R11 equals L3 equals D. The original plaintext is Hello World.